to talk about Java iterable interface, which represents a collection of objects that are iterable, meaning they can be iterated. So as we are going through this iterable in your list chapters, let's also kind of look at how this Java iterable is used in the context of code. So what you hear is see here is the online Java ID, one of those by REPL. In this example, we have a main class. What we want to do is to make sure that we can kind of emulate a list, right, in Java that we can iterate through. So first thing we need to do is to import java.util. Specifically, we're going to be using array list. So this array list is going to have, it's going to be a part of the Java util. So we're just going to use the extras because we might be using other features. To begin, we would like to create a placeholder array list starting from scratch. Let's say this array list. Array list is simply just an array with a dynamically sizable array buffer. And this is represented in the new array list interface. So this dynamically creates an instance of a list, and inside this list is what we can add stuff to it. One. So for all intents and purposes, let me just add some elements to it. So this list now is a basically a quote unquote collection of 3 elements. As you know, using your Java knowledge, you can iterate through this list, as using a for loop. In Java, you can specifically go through it using the for, right? So this one allows you to kind of go through every single one of these elements one at a time by printing them out one at a time to the console. So let's just make sure that this whole thing runs. Okay. You should be able to see the 3 elements in here as we see. So this is kind of the for each loop that we may use to iterate the elements of the list, right? The reason why we can do this is because list itself implements a collection interface, right? This interface collection allows you to kind of go through using the for loop to iterate through each element, as we saw, previously in your collections ADT. Now, let's introduce this concept of iterables. So collection interface also implements iterable interface. So this Java iterable interface allows you to create what's called an iterator, which is also another interface. But because we're using interface polymorphism, we can invoke, for example, this list iterators. And with that iterator, through these iterable interfaces, we can then effectuate the iterations methods on these collections to grab every single one element out. So the replacement for line 10 to 12 is pretty simple. In this case, we already know that array list implements collection, which implements iterable. So there's nothing to implement further. We can trust that this list has already got a method to get its iterator out. So the first thing we need to do is to ensure that we call the iterator. This iterator could be invoked by virtue of calling the list iterator. Okay. Now this is already done in Java, and so we don't have to implement it. So with this iterator, which iterates essentially every single element inside this list from a read-only style. Without using array indexing, allows you to invoke its has next and also next methods to get the elements out. So iterator has next returns a true or false, right? This is a Boolean. If there is more elements that you can iterate through, get them. So for each element that we are about to touch on or traverse, we can simply just invoke the iterators next to get the elements out and then print it, accordingly. So this is how we use the iterator method to get the elements. So let's make sure that this works by printing this out. Okay, so we should be able to get the elements out that way. So let's just take a look at what this is. So for any data structure that implements an iterable, you can invoke on this iterable's iterator method. This iterator method encapsulates the underlying buffer by returning iterator on top of that buffer to proceed with the hash as the next. And that allows you to, essentially, this is just a pointer, right? That jumps from one element to the next in a sequential order, starting with the very first element inside that list. Hash next returns a, if there is more elements, can I continue, right? The Boolean. And then iterator.next pulls that elements where this iterator pointer is landing at any given moment in time, allowing you to fetch the elements that way. Notice that we don't use the sequential array indexing in this method. So this is a pretty efficient way of ascertaining elements inside. However, iterator is not without a cost, right? So every time you invoke on a list iterator, this creates an instance of an iterator, and that's, memory, right? Consumptions, which if done, over millions and millions of iterations might incur some small, cost to time. And for this, you would not probably want to use the iterator. An array indexing using a for loop might be just as efficient, actually, if not more efficient in that matter.